Now we are being given some equations that must be graphed, but in integers and not natural numbers. This time the negative numbers are going to count. b greater than -2, all of the integers that are greater than -2 are over here. They include -1, 0, 1, 2, 3, and on in the positive direction. It's very similar to the answer that you would get if it was graphed in natural numbers, except the -1 has to be included in the answer. The -2 cannot be part of the answer because it is not greater than itself. c less than -3. I've made my number line a little differently here because I realize I need some numbers like -4 and -5 that are further to the left than I was showing with the others. The numbers less than -3 are all over here. -4 is less than -3, -5 is less than -3, and on in the negative direction, all of those numbers are less than -3. The -3 is not part of the answer because it is not less than itself. d greater than 2. The integers greater than 2 are the same as the natural numbers that are greater than 2. They start with 3, and they go on in the positive direction. And 2 itself is not part of the answer, it is not greater than itself. e less than 1. 1 is not less than itself, so 1 is not part of the answer. 0 is less than 1. All of the negative integers are less than 1. They are all part of the answer. And on forever in the negative direction. Here are some more examples where we are graphing on the number line within the universe of integers. These examples have greater than or equal to and less than or equal to symbols. Things will work very much the same way with only slight differences. y greater than or equal to -2. -2 is equal to -2, so it's part of the answer. And then all the numbers greater than -2 are part of the answer. Going on forever in the positive direction. f less than or equal to -3. Again, I have drawn my number line a little differently so that some numbers further to the left on the number line will show. The numbers less than or equal to -3 include -3 itself, -4, -5, and on forever in the negative direction. g greater than or equal to 2 looks the same as it would look if I was graphing it within natural numbers. 2 is part of the answer, 3 is part of the answer, and on forever in the positive direction. And e less than or equal to 1. 1 is equal to itself, so it's part of the answer. 0 is less than 1. And all the negative whole numbers are less than 1. So they are part of the answer, going on forever in the negative direction. When we graph in real numbers, there are some important differences to the way we do it when we graph in natural numbers or integers. Let's look at these examples: n greater than or equal to -1, p less than or equal to -3, w greater than or equal to 2, a less than or equal to 1. All four of these examples have the or equal to line underneath the symbol. n greater than or equal to -1. The number equal to -1 is -1. We have to put a dot here. It's part of the answer. All of the numbers greater than -1 are over here to the right. But we can't just put dots anymore, because working with real numbers, we have to find a way to include all of the fractions and decimals that exist in between those whole numbers. And the way to do that is with shading. Starting at -1, we shade to the right, and then we put our arrow, or our 3 dots, to indicate that it goes on forever in the positive direction. This tells me -1 is part of my answer, and all of the numbers to the right of it, including all the fractions and decimals, are also part of the answer. P less than or equal to -3. -3 is equal to -3, so it's part of the answer. I put a dot. All of the numbers less than -3 are over here, so using shading, I show that they are part of the answer. and I put an arrow showing that it goes on and on forever in the negative direction. W greater than or equal to 2. 2 is equal to 2. It's part of the answer. All the numbers greater than 2 are over here. I use shading to show them. And then I make an arrow to show that it keeps going. A less than or equal to 1. 1 is part of the answer. I put a dot there. All the numbers less than 1 are part of the answer, so I use shading to show them. And then put my arrow to show that it goes on and on and on forever in the negative direction. Now it's time to look at graphing equations that have greater than and less than, instead of greater than or equal to, less than or equal to, when you're graphing within real numbers. C greater than -3. The numbers greater than -3 are all these numbers to the right of -3 on the number line. -3, though, is not greater than itself, so it is not part of the answer. How do we show that it is not part of the answer? What we do is we put what we call an open circle around it. We don't fill in the center of the circle, and that shows that we are saying -3 is not part of the answer. But we are shading from that circle all the way in the positive direction and putting an arrow to show that it goes on forever in that direction. This allows us to make it clear that all those fractions and decimals between -3 and -2 are part of the answer. They are all numbers that are real and that are greater than -3. But -3 itself is not part of the answer. Knowing that, we can graph Q less than -1. -1 is not less than itself, it's not part of the answer. We put an open circle, and then we shade all the numbers less than it and put an arrow showing that it goes on forever in the negative direction. X greater than 2. 2 is not part of the answer, but all the numbers to the right of 2 are. We put our arrow. H less than 1. 1 is not part of the answer. We put the open circle, and then we shade all of the numbers to the left of 1 and put our arrow. This is how you graph equations in real numbers that do not have the extra little line that means or equal to in the equation.